Hello everyone, this is Saipriya. Today we are discussing limits. Limits is nothing but reaching a particular point. For example, if you take x-axis and a point A, the limit of a function at A is nothing but the value of a function when it reaches nearby A. It can reach A by two ways. Either it can reach from left hand side or from right hand side. When it reaches from left hand side, it's called limit extends to a minus f of x. Let the function be f of x. So its limit extends to a minus f of x. When it reaches from right hand side, the limit extends to a plus f of x. Here a minus means x is less than a. And when it is extends to a plus means x is greater than a. Limit has no relevance with the value of the function at a. That means even if the function doesn't exist at a, the limit can exist. Next, coming to some standard results. Yeah, limit extends to a plus a. Sorry, limit extends to a x power n minus a power n by x minus a is equal to n into a power n minus 1. And this is the continuation for the first one. Limit extends to a x power n minus a power n. Okay, this is m, this also m. Limit extends to a x power m minus a power m by x power n minus a power n. This is m by n into a power m minus n. In these two cases, a is a fixed constant. A is a fixed constant, but x is a variable. X moves in the neighborhood of a. X moves in the neighborhood of a. The limit is nothing but value of this function when x reaches a. In this case, the function doesn't exist at a. Like it becomes 0 by 0 form. When we substitute a power n minus a power n by a minus a, it becomes 0 by 0 form, which doesn't exist. As we already said, that limit has no relevance with the value of the function at that point. Even if the function doesn't exist at that point, the limit can exist, and this limit is n into a power n minus 1. Similarly, the second one, in the next classes, we will see the derivations of these results. Next, third one, limit extends to 0 sin x by x. Even in this case, the value of function at x equal to 0 doesn't exist. But the limit exists, like when x moves in the neighborhood of 0, this value tends to 1. So the limit is nothing but reaching of that point. The limit when x reaches 0 is 1. The same case with sin inverse of x and even sin hx. Same with tan x, tan inverse of x and tan hx. Next, in fifth one, limit extends to 0 e power x minus 1 by x. Same here, the x is variable, and this function when x reaches 0, this function reaches 1. Hence the limit of this function is 1. In the sixth case, limit extends to 0 a power x minus 1 by x. Here x is a variable, but a is a constant, fixed constant. A doesn't change, only x changes. So the answer is limit log a base e. In the limits case, the answer should be in the form of constant, not variables, because we are already assigning the values for the variables. When we try to evaluate this limit, it may not directly exist at that point, but on continuous evaluation, there is in one step, it will reach to a case where we can substitute the value and can get the limit. So the answer must always be in the form of constant. The next one, limit extends to 0, 1 plus x whole power 1 by x. This is E. This one will be the continuation of this one, like limit extends to infinity. Here limit extends to 0, but in the next case it is limit extends to infinity. 1 plus 1 by x whole power x. Just compare this and this with this one. Here x tends to infinity, that means 1 by x tends to 0. Here x is replaced by 1 by x and 1 by x is replaced by x. So limit is nothing but dummy variable. Even if the variable is changed, the limit won't change for the same function. Let us consider y equal to 1 by x. If x tends to infinity, then y tends to 0. Then 1 plus, it is given 1 by x here. So 1 by x will be y and whole power x equal to 1 by y. So this looks similar to this one. So the answer will be E. Yeah, now we will see this note. X, sin inverse of x, sin hx, tan inverse of x, and tan hx belongs to the same family. It means it is just easy to remember that here we have seen that sin x by x equal to 1, sin inverse of x by x equal to 1, sin hx by x equal to 1. And tan x by x equal to 1, tan inverse of x by x equal to 1, tan hx by x equal to 1. That's why these all belong to same family. When we remember this, no need to remember all the limits. Next, consider this example. 1 my limit extends to 0, 1 minus cos ax by x square. That 1 minus, we know that we know that 1 minus cos theta is equal to 2 sine square theta by 2. Similarly, there is another formula, 1 plus cos theta equal to 2 cos square theta by 2 t square. Next, here theta equal to ax. So 1 minus cos ax will be 2 sine square theta by 2, where theta is equal to ax. So ax by 2 by x square. Multiply and divide with ax by 2 by, here multiply and divide with a square by 4. A square by 4 into x square into 4 by a square. These two expressions are just the same. Just I'm evaluating the limit. Here it becomes 2 and a square by 2. Limit x tends to 0. A square by 2 into sine square ax by 2 by ax by 2 whole square. Even these two are the same. It's just the process of evaluation. Here when x tends to 0, as I have already said that a is just a constant. X is the variable. It is changing. So even if the x changes, a doesn't change. So we can take that out of the limit. We can take any value out of the limit only if that is constant. If that won't change with the change in the variable. As a is a constant, we can take that out of that and limit extends sin x sin ax by 2 by ax by 2 whole square. We have already seen that sin theta by theta, limit theta tends to 0, sin theta by theta is equal to 1. Here x tends to 0, that implies x tends to 0, that implies ax by 2 tends to 0. Even as a is a fixed constant, let's take for example a equal to 9. When x tends to 0, x may not be exactly 0, but it is close to 0, like 0.00001. It always tends to 0. So ax by 2 tends to 0. So this can be taken as a square by 2 into limit x tends to 0, that implies x by 2 tends to 0 sin x by 2 by ax by 2 whole square. As this is 1, limit theta tends to 0, sin theta by theta is equal to 1. Even this looks the same. So this value is 1, 1's whole square. Like we can separate square like this, like we can take the limit outside it. We'll prove in the next sections, but whole, it will become whole square. If this is 1, whole square will also be 1. So answer is a square by 2. Just go through it, the same one, x by 2 a square, that is a square by 2. Yeah, we'll discuss it now. Limit n tends to infinity. Limit n tends to infinity, x power 1 by n minus x power 1 by n plus 1 into n square. In these all the cases, x is the variable, but here x is a constant because n is only n is changing here. Only n is changing here. N is changing here. Here x is the constant and n is the variable. So we can apply. This looks similar to this formula, where a is a constant and x is a variable. So here x is a constant. Remember, here x is a constant, only n is the variable. So we'll try to make that as limit n. Change the size. Limit n tends to infinity. We'll take x power 1 by n out of this. So when you take x power 1 by n plus 1 common, this will become x power 1 by n minus 1 by n plus 1. Like even try to elaborate this one. This looks similar to this one. So x power 1 by n plus 1 common, that is x power 1 by n minus 1 by n plus 1 minus of 1 into n square. N square is a constant. Now, okay, I will just elaborate the solution next. Infinity into x power 1 by n plus 1. X power 1 by, this means n plus 1 minus of n by n. So this becomes n into n plus 1 minus 1 by, we'll multiply and divide as it looks similar to this one. Similar to this one, we'll multiply and divide with 1 by n into n plus 1. We are trying to change this problem in this form, so that we can solve that. Okay, as we are multiplying, we should even divide with it, n plus 1. Both the equations are just the same. I'm trying to evaluate the solution, evaluate the problem. Okay, next, this one becomes finite when n tends to infinity, x power 1 by n plus 1. Infinity plus 1 is also infinity. Like infinity is so big value, even if you add a small any number, it will become infinity. So n plus 1 is also infinity. 1 by infinity is 0. So x power 0. X power is anything which whose power is 0 will be 1. Like any finite value whose power is 0 is 1. So we can take that out of that. So x power 0 into limit n tends to infinity into, we will take even this of n square by n into n plus 1. Here this looks similar to this one. So this is log a base e. Here x is a. So log x base e. Yeah, I have forgot to tell, the limits are changed, the boundaries are changed. Here x tends to 0, here n tends to 0. When n, just look at, when n tends to infinity, 1 by n into 1 by n into n plus 1. Infinity into infinity, which is always infinity. So 1 by infinity will be 0. So even this looks similar to this one, like when n tends to infinity. So I can elaborate it more. This. So this can 1 by n can be taken as y. So limit when n tends to infinity, 1 by y equal to 1 by n. So 1 by infinity, y tends to 0. X power, yeah, we have already elaborated that one. So we can, this is already x power 0. Next 1 by n into n plus 1. That means 1 by y into 1 by y plus 1. Minus 1 by 1 by y into, okay, it's 1 by y, 1 by y plus 1. I'm clear. I'll drop this. I will explain you once again. Okay, I think I'm clear till here. Yeah. I'm clear till here. Yes, we have taken 1 by x power 1 by n plus 1. Yeah, that's okay. Then when x tends to infinity, this will become 1 by infinity. So this will become 0. So x power 0 is taken common. Next, as we have multiplied and divided by 1 by n into n plus 1, n plus 1, we'll take even that common. So you have to be more clear with n. I have just rearranging the terms. Into limit n tends to infinity, x power 1 by n into n plus 1 minus 1 by n into n plus 1. So we have to evaluate this limit. As I have already said, this looks similar to this one, where here a is the constant, but here x is the constant. But the limit here is x tends to 0, but here n tends to infinity. And where n is like, I think you have understood that n tends to infinity. But the things are changed, like here x tends to 0, a power 0 form. A power, the power became 0, even the base, the denominator became 0. Same here, when n tends to infinity, this will become infinity. 1 by infinity will be 0. So the power here became 0. X power became 0 and 1 by this one also became 0. So try to elaborate it, you will understand. This looks similar to this one. With the limits, x power became 0 by even denominator became 0. So this will become log a base a. Here a is nothing but x. So log x base a into n square by, no, I should not take n square here. It should be in the limit. It should be in the limit because n is nothing but, n is a variable here. N into n plus 1. Limit n tends to infinity. Here log x is constant, so we'll take that out of it. I'm just moving here as I have no space there. Limit n tends to infinity, n square by n into n plus 1. So you will get to know much more in the next sections when the power of numerator and the denominator is same. When the variable tends to infinity, this will become 1. So the answer will be log x base e. Yeah, once you go through the solution. Yeah, next, limit extends to, yeah, this one. When f of g of x is a bounded function, let me tell you the definition of bounded function. Like, if the value of the function lies between Net two fixed values. Consider like sin x is a bounded function because its values always lie between -1 and +1. Even 5 sin x also, these lies between -5 and +5. This one fractional part of x which always lies between, yeah, even it, 1. These values or these functions O's values lie between two fixed values are known as bounded function. Yeah, we can take many examples like cos x. Cos x tan x is not bounded one. Cos x is bounded. Next, fractional part is bounded. Yeah, okay. Limit extends to a when g of x is bounded as a g of x is bounded, limit extends to a f of x into g of x. If g of x is bounded and limit extends to a f of x equal to 0. If it becomes 0 when extends to a, f of x becomes 0 and g of x is a bounded function, then this limit becomes 0. Becomes 0. Yeah, I'll explain it like if any number multiplied with 0, this is 0. Any finite number means bounded means it's finite. Its value is finite. When you say it lies between two numbers, then those as they are finite numbers. When we multiplied with any finite number with the number very near to 0, like 0.0000001 into some, let that number be 100. So these will become 0. Hence, when g of x is a bounded function, the limit turns as 0. Okay. This is not the case when g of x is not bounded. Bounded means if g of x takes the value infinity, infinity is not infinity, then this can't be the case. It can't be 0. Next, let's take example. Limit extends to infinity sin x by x. You may accidentally tell this as 1 as we have learned in the previous section, but here limit extends to 0. This means here x reaches nearby 0, but here x reaches nearby infinity, means very large value. Limit extends to infinity sin x into 1 by x. Here f of x equal to 1 by x. When limit extends to infinity, f of x tends to 0 because 1 by infinity tends to 0. So f of x tends to 0 and sin x is a bounded function. Means sin x lies between -1 and +1. And +1. Hence the limit will be sin x, as this is a bounded function, bounded one, and that limit tends to 0. So the overall answer will be 0 according to this one. Next. And the same with cos x by x. 1 by x is f of x. That f of x tends to 0 when x tends to infinity, and cos x is a bounded function. So the answer will be 0. Now consider this one. Limit extends to 0 x into sin of 1 by x. As I have already mentioned, the function need not exist at that point for limit to exist. As it is, this function is not defined at x equal to 0 because it become 1 by x is not defined. So we'll take in the neighborhood of 0. This let f of x is x, limit extends to 0, f of x will be 0. And even if it is when it tends to 0, even if it reaches very large value, when it reaches nearby infinity, it's in a very large value, sign of that one is always between -1 and +1. I will repeat it. even the 1 by x may turn to infinity. Infinity or nearby infinity. Sine of, but wait, but sine of 1 by x is always finite. Sine of 1 by x is always finite, and it lies between -1 to +1. So this is a bounded function, and this tends to 0 when x tends to 0. So the product according to this one will become 0. Yeah, we'll do this one. Sine of